All right, so this is just going to be a continuation of what we were doing on Thursday. What I decided to do is change the notes just a little bit and go towards specifically the type of logarithmic problems that you need to do your homework. Okay, so it's not going to be anything crazy. It's just going to be what do I have to do my homework, right? Sweet. Okay, so what we're going to do, this is going to be example number 1. So what you're going to do, let's see here. Let's go with 3, 4, 5, 6, 7, 8 is equal to 1, 2, 3, 5. And then let's go 1.05 t. All right. So this is our compound interest formula. So this would be our principal. This would be our 1 plus r over n. Okay. It looks like n is going to be 1. So it's compound annually because time is only t. Okay. This would be our b. So we're looking at how long it took this much to grow into this. Okay. So the first thing you're going to do is we're going to divide by the principal amount to both sides. And let's just go 3 places after the decimal, okay? And this is just going to stay like that, t, all right? Now from Thursday, I told you to do what from here? Natural log, okay? So we're going to take the natural log on both sides. So it would look something like this to kind of show my work. So that goes down, goes like this, and then the t comes in front, and then we're going to have natural log of 1.05. Okay? And now what I can do is I can take natural log of 1.05 and divide it over to here. Okay? So natural log by the natural log of 1.05. So it'd take 115 years for $1,035 to grow to 345,000. Just a little bit of time. Okay? Good? Okay. All right. So the second type of problem you need to be able to do is you need to actually convert it to look like this. A is equal to B to the power of C. All right? So what that is, let's just do that this time. 3, 4, 5, 6. So all we're going to do is take this equation and we're going to divide by 1235 again. All right. Now, here's my A, right? Here's my B, right? And then that is my C. That's all you have to do. You don't even have to solve it. You're just taking this number here and dividing it over. That's it. You're making it into A equals B to the C power. Okay? That's it. Good? All right. Example number 3. we're going to have 12,800 is equal to 640, and we're going to have 1.0082t. All right, give you a second. All right, this time we're going to solve for t again. We're going to solve for t, but instead of using our calculators, we're just going to leave it in terms of our logs. Okay. Okay. So divide by 640 again. All right, so we got n is a is equal to b to the c power. How do I get that power down? What do I need to take? Okay, let's take the natural log. I'm going to bring down that 2t because that's the power. So it looks like that, correct? All right, so then I'm going to divide by everything except for that t. So then that is my answer. I'm going to leave it alone. Okay, so the question was, why don't these cancel out? They don't cancel out because they're kind of a function like the square roots. So over here we have the square root of 3 over the square root of 5. The square roots don't cancel out. Okay, it's a square root of 3, it's a square root of 5. Those are numbers. If we had square root of 2 over the square root of 2, that's equal to 1. So if we had a natural log of 20 over the natural log of 20, that cancels out. But the natural logs is actually a number. Okay, so what we got, the next one, is you got the log, and this time you need to change. Instead of doing natural log, we're going to do logarithmic. Okay. Now, usually a log is going to be base 10, but we can actually change it to be something like this. So that's going to be log base 102, and then we have 2.875 divided by 12. Okay. Now, there's some calculators that will actually allow you to type in that base, like just like that. Okay. And there's other calculators where it doesn't. Okay. So if you're lucky enough to have one of those calculators that actually types it in for you, let's see here, log, I'll turn it on. Mine doesn't. Okay. My graphing one won't do it, but I know my colored ones over there will do it. Okay. So I'll show you that in just a second. So mine won't do it. That's bad, right? Yeah, it's bad. Okay. So what we're going to do is we're actually going to take the log and leave it as base 10, and you're going to go in at 2.875. You're in the seat, 2 seats behind Isai. Like that. Okay. So this number right here gets to come down into your denominator. This one goes into your numerator just like that. Now the 12, we're just going to kind of do this for a second. Okay. That's where the 12 ends up because it's still on the bottom. Okay. Now, can we have a fraction inside of a fraction? Good job. No. So we're going to take this, multiply it by 1/12 and 1/12. Okay. So then my equation is going to be the log of 2.875 because that's times 1, right? And then I'm just going to put that 12 out in front, like that. Okay. And then use my calculator. And we should get 4.4. Okay. Okay, so our last one, just to make sure we got it, is going to be this guy, equals 64,000, or 6,400, excuse me. And then we're going to have 1.00125 power of 6n. So just like we've done in the past, we divide by 6,400. That equals 1.05. And we have 1.00125 6n. And I'm going to take the log, so it'll give me the same thing. Was going slow. So I took the log of both sides. I can do natural log or log. If I change my base like we do number 4, I do need to use the logs. Okay. So now I'm going to divide by 6 log 1.00125. 6 log 1.00125. So we go log 1.05 divided by 6 log 1.00125. So this time we're not solving for time, we're actually solving for the time that it is compounded. Yeah. Just like that.